Hello everybody, my name is Rafael and I will be presenting carbon sequestration potential and wood quality aspects of Southern African trees extended to agroforestry systems and assessment through 3D data. We are working in Southern Africa with agroforestry systems and we would like to know everything about the trees in these landscapes. Therefore, we should go for non-destructive methods such as terrestrial laser scanner, coupled with cylinder fitting algorithms. We would like to explore everything about the structure and function of trees in these landscapes, such as the provision of ecosystem services, tree-crop livestock interactions, and the simple provision of goods such as timber and non-wood forest products. Here I show you a first point cloud my colleagues produced in a site in Namibia, Hamoi Forest Reserve, which is a silvipastoral system, a typical savanna woodland with grazing, managed by fire in a yearly base. The tree density in this area is 144 trees per hectare, and this forest formation is composed mainly by Fabaceae species. This scan was produced from 6 positions in an irregular grid design. The positions are 25 meters and 70 degrees apart. The conditions in the landscape were leaf-on conditions. And the first step processing this data was through segmenting the trees, filtering out the leaf points, then using tree QSM to obtain volume estimations for these trees, and finally calculating the uncertainty with 30 model runs for a tree. Volume was converted with a wood density of 690 kilos per cubic meter to biomass, and from the biomass we assumed 48% of it being carbon. You can see here the diameter at breast height distribution of the trees in this site. We ended up with 1/3 of hectare, 65 trees, and so 180 trees per hectare. And you can also see the volume, the woody volume above ground of these trees in the graph, in the lower graph here. We also found an above ground woody biomass on a hectare basis of 35 megagrams. And you can see also that most of it's actually allocated in the tree branches and not in the stems. The same reflects the situation of carbon stock, so you have most of the tones being the branches and approximately the same quantity in stems. Here you can also see that most of the trees have below 200 kilos of carbon, and so carbon is allocated rather in small trees that are in more quantity in this area. And in terms of wood quality, we compared tree height and tree length so that you can check that actually many trees are bended, and we have had some difficulties when fitting cylinders to the point clouds because maybe resolution was too low, sampling intensity was too low. Following steps, we want to include more agroforestry systems. We will check effects of increased sampling density. We will add tree species information, refine all the uncertainties in the volume calculation and biomass conversion. We will try also other filtering techniques and explore more on the point clouds we produce at tree and landscape level. Thank you very much and get in touch if you're interested. See you next time.